Okay, so we're going to talk about scatter plots in section 1.6. A scatter plot is a graph that shows the relationship between two sets of data. Those two sets of data are graphed as ordered pairs on a coordinate system, meaning it's just two sets of information, x values, y values, that you put on a regular xy graph. So for example, this table shows Miranda's quiz scores for the past 5 weeks. You can see week 1, her score is 50%, week 2, 51%, week 3, 65%, week 4, 72%, week 5, 80%. As the weeks go up and time passes, her score is also increasing, so looks good for her. And what we want to do is make a scatter plot of the data. So that means we need to create a graph. Normally we'd want some graph paper, but if you just have regular notebook paper like most of you do, we're going to do that using a ruler and make a nice little sketch here. So I can see my x values are weeks, it's independent. My y values are the score, it's the dependent variable. My score depends on how many weeks have passed. So x here, y here. So my y values have to go up to 80. So I'm going to want, let's say, at least 8 lines, maybe making them worth 10 units each. So here's 1, 2, 3, 4, 5, 6, 7, 8. There we go. Give me a little bit extra room there. So my y values, and since it's scores, I'm going to write on here score, so I know what that is. And then my x values down here. And I'm only using the positive numbers right now, which is why I really only need this first quadrant. But my graph does extend in both directions, so I need arrows and I need to show that extension there. And my x values represent the weeks that have passed, so I'm going to label that as well. So you have 10, 20, 30, 40, 50, 60, 70, 80 is as high as we go, but we can go further. And then on my y's, I'm going to space these out nice and evenly, best that I can. 1, 2, 3, 4, 5 weeks, and it can extend further as weeks continue, but we don't need to. We just need to go to 5 for this scatter plot. Okay. So week 1, her score was a 50%. So week 1, 50%, and I plot that point right there. Week 2 was a 51%, so week 2, barely going up above the 50. Week 3 was 65%, so week 3 I'm going to go up to 65. That's halfway between 60 and 70. And plot that point. Week 4 is 72%, so week 4 I'm going up to 72%, just a little bit above 70. And week 5 was 80%. So in week 5, I'm going to go all the way up until I hit 80% right here. And I can see this is not a perfectly straight linear pattern. It doesn't look like a line if I connected it. It is kind of zigzagged or wiggled around a little bit. But it is a scatter plot. So I think scatter, the points are kind of scattered. They may follow some general trend like this, like it looks like they're going up, but they don't have to form a perfectly straight looking line there. Okay, a scatter plot may show a pattern or relationship from the data. So there's 3 different types of relationships that we might see. You could have a positive relationship, you could have a negative relationship, or you could have no relationship. So for each of these, you have your graph. Your y-axis here, and your x-axis here. So in a positive relationship, my points look like they form a positive slope. So it would be going in some kind of upward pattern. Maybe scattered, but it looks like they're moving upward like this does. As my x values increase, my y values also increase as I make those points. For a negative relationship, it'll have more of a downward looking pattern, similar to if something had negative slope. So this one, as my x values increase, my y values actually decrease as I follow this down. And if there's no relationship, then my points are all scattered just all over, and it doesn't look like they're moving upwards or downwards, either one. They're just scattered all over the place. So if I look back here at Miranda's quiz scores, I can see this looks like an increasing pattern. As my x values increase, my y values also increase. They both go up together. So then I would say that this right here has a positive relationship. And I can describe that by saying, as the number of weeks increase, her score also increases. Okay, now we're going to determine whether a scatter plot of a certain set of data might show a positive, negative, or no relationship. And you're going to explain your answers. In some of these questions, I won't actually give you any data. I won't give you a table or any numbers. I will only give you a situation, such as fat grams or grams of fat and the amount of calories in food. So what I'm asking is, if I took fat grams and I took calories that's in food, if fat grams increases, would the amount of calories usually also be increasing? Or if fat grams increased, would the number of calories usually decrease? Or is there no relationship between these two things at all? Well, as the number of fat grams in food increases, the number of calories should also increase. We would assume that those would both go up together as you eat more food. So if I were to sketch that out on a graph, it would most likely look like this. I'd have fat grams, calories. I could see the fat grams and calories usually going up together. So the more fat that's in food, the more calories it likely has. And this is something I would call a positive relationship. Another example, I'm going to ask about the time spent relaxing and blood pressure levels. So let's think. As you spend more time relaxing, as you relax more, should your blood pressure go up because you're stressed, or should it go down because you're de-stressed? And the answer to that would be, as you relax more, your blood pressure should go down. So as you spend more time relaxing, your blood pressure levels should go down or should decrease. And if we sketch that out on a graph, like could see here. Time spent relaxing. And blood pressure. As this goes up, this goes down. And it would look something like that, and I would say that there is a negative relationship. And one more. I could also ask you about the relationship between the age of a child and the number of siblings. So as the age of a child goes up, as a child gets older, does that affect the number of siblings that the child has? No. If a child is 5 years old, yeah, they could have 1 or 2 or 3 or 4 siblings. If a child is 50 years old, they could still have 1 or 2 or 3 or 4 siblings. Or they could have none. A 5-year-old could have no siblings. A 50-year-old could have no siblings. The age of a child or an adult or any person does not affect the number of siblings they have. Is it possible that as they get older there could be a younger sibling? Yes, it's possible. But as you get older, that doesn't necessarily mean you have more and more siblings. You could, but it doesn't necessarily mean that you do. So, the age of a child does not affect the number of siblings. On a graph, this could be age, this could be siblings. Child could be, let's say this is 3 years old and have 2 siblings. A child could be 10 years old and have 1 sibling. A child could be 7 years old and have 5 siblings. Or 8 years old and have no siblings. Or 1 year old and have 1 sibling. Or 4 years old and have 6 siblings. It could be any combination. Your age does not necessarily affect the number of siblings that you have. So there would be no relationship.